So good morning. Many are joining. Good morning, dear students. Welcome back to Python class. The agenda for today's class is about doc test and doc test examples, how exactly external documents can be supplied to doc test. Finally, we'll discuss about Python try exception. So here it is called try exception. In Java, it is try catch. Just try exception. We'll also discuss user-defined exception, how to define, how to use it. So that's the content of today's discussion. And at the end of the class, I'll give the assignment. Okay. Basically, docstring, we know very well, any function or any class or any method you write, what happens inside that, you write a comment as a first line. So the first line comment, whatever you write inside a function or a class or a method, is called docstring. This will help you to understand about why this particular function, method, or the class is used for, written for. So in the help text, it will definitely give you a lot of information. And coming on to doc test. Doc test is actually semi-automation testing. So you know you're already studying testing, software testing. So if you want to test your code automatically, definitely you should make use of this doc test. Let us understand first. This doc test has a good relation with the docstring. The doc test has to be done through docstring. Okay, that is one of the very important thing. Doc test lets you to test your code by running the test cases embedded in the documentation. It is docstring, and verifies that they produce the accepted results. Look at here. In this example, I'm writing the test case. Let me choose annotation. Okay. Yeah. Look at here. This is a test case. This is a test case 1. This is a test case 2. And what is this? Why we are using these test cases? We are calling this test case for my function. We are writing my function. And for my function, we are passing 2 and 3. And expected value is 6. If you get the expected value 6, then this test case is passed. If you pass A and 3 and you get 3 A's, okay, it is test case is passed. If it is not, if it is expected result is not there, so then definitely it will throw an error. We call it as a test case failure, failure of test case. This is unit testing. We do unit testing. So far, you are heard of unit testing, right? In software engineering. So today, I'm really demonstrating unit testing in Python. How exactly unit testing has to be done. Okay. Especially if when you look into doc test, doc text works by passing the help text, that is test cases, that is to you are passing an example values and running them and comparing the output against the expected value. So here 2 and 3 are the values that you are passing to the function, test values, test case values, and you should get 6. Once you get 6, this is the expected value you are giving. So you are giving the input also, you are giving the expected value also. Computer will execute by itself, and once it completes its execution, what it will do? It will compares with the expected value. The output, actual output is compared with the the expected value. If the value is, same, then test case is clear. If the value doesn't match, definitely it will throw an message stating test case is failed. So that is the concept of test case. And test case, you can do it with docstring. Couple of years back, I saw in a question paper, explain the uses of docstring. Everybody wrote about only docstring is a help string that explains the usage of this particular function or a class or something. They explained, but nobody spoke about doc test. Docstring is again used to do unit testing. That is doc testing. Doc testing, it is done through unit testing. This docstring. So docstring has two usage. One, it will help. Second one, it is used for doc testing. Let us see how exactly practically we have to do. In the next slide, we have the doc string. Look at here. How to do doc testing? Please note down in your book. Okay, I have a file called mul.py. Okay, let me go back to the previous slide. In the previous slide, whatever the function that I have written, you observe the name of the file. You observe the name of the file is mul.py. This is the name of the file. Observe here, this is the name of the file. So I have written the same thing. My function a comma b, which returns a into b. That is the multiplication result of a and b. It is returning. And you are writing test cases in the doc string. Same thing. You look into the next slide. Look at here. What I'm doing, I am doing a document testing Python minus m. Python minus m. I changed the color of my pen. Yeah. Python minus m. Doc test. So doc test is a module. That's why I write it as minus m. Minus m. Minus v indicates verify. What is the file name? mul.py. Automatically it is trying. First, it will take the first call. 2, 3. Trying. 2, 3. Expected value is 6. So, and whatever computer generated value is 6, whatever you have got is the same. So it says it is okay. First test case is okay. Second test case, A and 3. Expected value is triple A. It is also, the computed value is also okay, right? Finally, after this test case, it is generating the, report. One item had no tests, and number of tests. One item has number of tests. That is mul. Mul is the test item, and there are two tests that we have taken care. That is two test cases. So one item, that is mul, is the item. On that, we have applied two test cases. So that is on mul.my function, we have applied two tests and two items. Two cases are also passed and 0 failed. And test is passed. See, this is the test report. Normally, if somebody asks in the interview or somebody questions in the examination or internal test, you are supposed to write, okay, doc test not only tests the given test cases against the given input, using given input against the expected value and the actual value received. And finally, it generates the report. Finally, it generates the report. That is very, very important. It generates the report. So you have to understand all these concepts, how exactly it works. Now, let me take you to my command prompt and show you. Just type cmd command prompt. I go to command prompt. Yes, I went. cd root. Yes, I went. And 1 second. Yeah, sorry. Yeah, command prompt. cd Satish. Now, let me open notepad mul.py. I've already prepared. It is there. This time I have written more cases, more test cases. In the slide, I have shown only 2 test cases. Now I have written 4 test cases. First test case is 2, 3. Second test case A with 3. That is character A with 3. Third one is 4.25 with 3. And minus 3 with minus 4. So I should get all these test cases. Now I close it. It is done. Okay, or else let it be open notepad and let me bring now. Now, in order to do my doc test, I should write Python minus m. M is for module. This doc test is the module. I'm using doc test module to verify the code that is written inside mul.py. As soon as I give, so what happens? The test case happens. Testing happens. So it tests with the 2 on 3 and expected value 6, and it says okay. Next, trying second test case. A and 3. Expected value is AAA and it got AAA. Okay, that is also passed. 4.25 into 3, you are passing. Expected value is 12.75. That is also okay. It is done. Next, trying with the fourth case, minus 4, minus 3. Expected value is 12 and you got to okay. So one item had a test, mul, and one pass all the tests, 4 tests in my function, and you worked on 2 items, and of course passed 4 tests passed, and 1 test 0 test failed. Now I'll write one more test case. Triple this one my function, my underscore function, and I write 3 comma a, and I should get sorry, I should use single quotes because double quotes. Okay, no problem. I can use double quotes also. That is not so, but better. Let me use single quotes, and I write AAA. Now observe, I have exchanged 3 and A. If I exchange, definitely it will throw error. It will not. You will not get error. That value. The expected value AAA will not get. So 3 into A is not possible. A into 3 is possible. Right? You know very well. Character multiplied by integer is possible. Integer multiplied character is not possible. Okay. Let us save this. File save. I save it. Let us come back and do the test case again. See, observe now. First test case, okay, fine. Second test case is also okay. Third test case is also okay. Fourth test case is also okay. Fifth test case, A with 3, that is also okay. Somehow it has taken, and no failure happened. No failure happened. A and 3, 3 into A is one and the same. Now, I purposefully add one more A. Expected value is 4, but actually you are writing it as 3. That means it should get 3, but you are expecting 4. And purposefully, I want to show you a failure. I want to show a failure. Okay. Look at that. First test case, okay. Second test case also okay. Third test is okay. Fourth is also okay. Fifth is not okay. Look at here. It is trying. It is expected 4A, but you got only 3A. So purposefully I did, error. Purposefully I did error. Just to show how test case fails. How test case fails. I did error, and one test item has no test mul, and one item had failures. 1 out of 5 test cases is in failure. 5 tests in 2 items, 4 passed and 1 failed. So even one test fails, the entire test case is invalidated. That means entire testing became failure. Test is failed. Even one test case fails, the entire testing is failed. So this is what the report says. And this is how you should do testing. This is how you should do testing. So remember the instruction. Remember the instruction. This is the instruction that you should never forget. Sorry. This instruction you should never forget. Please write down. And in today's assignment, you have to create the same demonstration with all test cases passed, and some test case you have to fail it. I want to see 2 outputs on the assignment. One is all the test cases passed. Another one is all the test, at least one test case failed. One is completely passed, another one is one failed. So test case passed and test case failed. So semi-automation testing, I want everybody to submit your assignment. So assignment for today is demonstrate semi-automation testing using Python. Semi-automation testing using Python. So this is what I expect from you. Okay, hope you understood. Anybody has any doubt? If it is clear, can I move on to the next one? At least say yes or no in the chat box.
Yes, sir.
Yeah, thank you, Chandru. Others also can respond. Okay, right. Okay, this is test passed. Similarly, I can also create a test failure also, so that you should know how exactly unit testing we can do it in Python. Right. So this is automation testing, semi-automation testing. Now, for this test, we used to give values within the doc string itself. But you can supply this doc string externally also. The doc string can be given externally also. And you can also give doctest help in a separate file. So external documentation, we call this concept as external documentation. Mixing text with your test case is not only the way to use doctest. Example, whatever we have embedded earlier, we have written the doc text as well as the test cases in the doc string itself. But suppose if you want to write something related to explaining the functionality of that particular program code, I want to give a comment. Really, it is not possible. So whenever you are doing doc test, all doc test cases you are writing in the doc string. But I want to use it for writing some explanation. In that case, you have to write it as a separate file. Separate file, the external documentation. The help for Doctest in help, Doctest in help is saved to a separate file, and doctest.in doctest in help.rst. It is a restructured text file. RST is nothing but restructured text file. It's a format generally the professional software professionals they use. They write the code, and the Doctest help, they'll write it in RST file, separate RST file. The example illustrate how to use the module are included with the help of this text, and the Doctest can be used to find and run the test. So the help text, separate documentation, it is written to explain how exactly things are working, how exactly the code is functioning. Along with that, we are also writing the document, test scripts also in the doc string. So let us look at here. The tests in text file can be run from the command line, of course, Python. Look at here. I can certainly write Python minus m, Python minus m, doctest minus v. So this is a module, and it is the verification. You can do it with this RXT file. So your test code is written in this RST file. So from the RST file, it takes the code and it will execute. Look at here, it will execute. It will execute. And finally, it will give the result. So this is also very similar. This is also very similar. And it is beyond your syllabus. So I'm just putting it so that you should get some knowledge about what is RST file. Restructured text file. It is mainly used for doctest help file. It is working as doctest help file. So that is a concept that we should understand. And coming on to yesterday, we started with while loop, and we got less time. So while loop, when we look into while loop is similar to if loop. It executes the code that is written inside that block, and if the condition is true only, it will keep on executing. And however, as opposed to if a statement executes only once. If a block is executed once. But while loop, it keeps on executing the block, continues, the loop continues until the condition value is true. Once the condition value becomes false, then it will come out. So that is the thing. So look at here, while condition, and you have the expression. So we have one example here. Look at here. Example is error is equal to 50.0. If the error value is greater than 1, you keep on dividing by 5. So, and print the error. So it keeps on executing, and it will display the error until the error value reaches beyond 1. So that will keep on doing it. So that is the concept, while loop. I think while loop will come in the next module. Since yesterday I explained Fibonacci series, it is required. Another very important, see, doc test, whatever we have seen, the semi-automation testing, computer did the entire calculation and compared with the expected values. Here, computer is executing by itself. Computer is executing by itself and comparing its result with our expected result. So, and it is display whether testing is successful or not. Sometimes, whenever during the program is running, we get errors. How to handle such errors? See, uh, runtime errors are errors you don't expect even in testing. So they get error only when it is running. So in order to detect that errors, we have to use try and except block. So try and except, try block and except block. Okay, the try block, what it will do? It will test your code for errors, and the except block will handle that errors. And these errors are runtime errors. Observe, these are runtime errors. During the runtime, you get the error, and it is handling. So your docs test, whatever you're doing, it is very close relationship with your try catch exception, try exception rise. So finally, block. So you have try block, you have except block, and finally block lets you to execute the code regardless of the result is try or except. So this is, here is one such example. So we have one such example, try print x, we are trying to print x. In case x is defined here, somebody tell, is x has some value? Is x has value in this example? X is not having any value. Since x is not having any value, what happens? It will generate name error. Your interpreter doesn't know what is x. So what it will do? It will definitely say it is a name error. When name error comes, it will print. Okay, uh, x is not defined. Some other errors other than this comes, it will print something else. It will print something else. So this is what you should understand. This is what you should understand from this example. Let me run this code. Okay, let me demonstrate this code from my Jupyter notebook. Anyhow, it is already there. So I write in the Jupyter notebook the heading first. Okay, demonstrate try except, try except statement. Okay, now let me write try colon print x except, except on name error print variable x not defined. Okay, else print some other problem. This is the code that we had in the example that we have displayed. I'll run this. Now, what happens? X is not defined. X is not defined. X is deleted. Sorry, X is not created at all. So it is displaying X is defined. X is not defined. So suppose if X is defined immediately, X is equal to 5. X is equal to 5. So this is finally block. It's just like finally block. In finally block, the testing is Successful or unsuccessful, this block is absolutely it will execute. Okay. Or I can certainly write no problem. Okay. If there is any problem, it will display the problem. If any other problem, it will write. Okay. If it is name error, it will display name error. Okay. If it is except other error, you don't know what is the error. Okay. If you know particularly name error will come, then you can write the name error. I don't know the name of the error. I just want to print some error. I don't know the name of the error. Okay. I can certainly display. Now, when I run this code, what happens? I get no error, no problem, no problem, because this code do not have any errors. It will not have any errors. If I get error, if it is name error, it will display name error, this value. Other than name error, some other error, it will display this, some error. For example, I just divide this by 0. It is arithmetic exception error, divided by 0 error. But since x is already defined, what happens? Name error will not get. Since it is dividing by 0, oh, you get division by 0 error. You're writing some error here. So when I run this code, you get some error. You don't know that error. Some error. You don't know that error and you write error. You can also print that error. What is that error? Okay. And you can also create your own user-defined exceptions. You can create user-defined exceptions, which you call it as rise. We can also use rise keyword to display user-defined exception. User-defined exceptions. Let us see how exactly user-defined exceptions we can run. We can run how exactly user-defined exceptions we can run. Okay. Look at this code, import math. I think I have already explained. I have given an assignment also, and you have already done. Finding the roots of quadratic equation by taking the coordinates of quadratic equation A, B, C. Okay. Import math, error, class error, exception. You are creating your own exception. For this, you have to use the class error. You have to write the class error, and you are supposed to take the exception, and you just write base class for all the exceptions. This is the base class for all the exceptions. Pass means end of the class. Now, imaginary root error. This is error. This is an error that you are writing class imaginary root error, which is taking an object of error, and the roots are imaginary. That is what the message that you are printing in this particular error exception. You are creating your own exception, user-defined exception, with the help of error class, and this is raised, and you are writing the document string raised when input values are too large, and okay, your user-defined exception you have written. Now, take the coefficients for performing calculation. Read the inputs. A is equal to int of input of A. B is equal to int input of B. Same way, int input of C. You take A, B, C values. Take then here discriminant you calculate. That is, in the try block, you calculate discriminant value. That is D is equal to B square minus 4AC. If d is less than 0, you cannot find square root of negative numbers. It is not possible. What do? You raise imaginary root exception or error. This is created by you, user defined exception. So you rise. See, look at here, try and rise. Try and rise. In the previous example, we saw try and except. Except is like catch block. Else block is the finally block. Okay. And solutions, find the solution. Solution 1, solution minus b, square root of d minus 2a by 2a. 2a. And we can also raise an arithmetic exception error in case if a value is 0. A value is 0. So anything divided by 0 is infinity, which is arithmetic error. And that we will write invalid operation error. So that is, and except imaginary error, you write imaginary roots. Else, the solutions are, first solution is 0, that is solution 1. Second solution is 1, that is solution 2. Let's just explain. So this is about executing the program using runtime exception handling, error handling. This is one example. Hopefully everybody should take screenshot. Before that, let me demonstrate how exactly these programs are executing. Okay. Yeah. Chandrasekhar, we are testing. We are testing on whether 40 minutes limit has been taken back by Zoom or not. So I'm just testing. It is 37 minutes past. Okay. Let us see. Meanwhile, by this time 10 minutes, this one is not showing in the 10 minutes, that is warning message is not showing. You see, that means it will allow beyond 40 minutes. Okay. So I'm just demonstrating the program. I just put it here. Yeah. Just put the first part of the program. Then the second part, I just copy it. Yes, just copy it. I paste it here. Yeah, my program is ready. Now, the same program, I just make it F11, full screen. Now, I think you can take screenshot. Okay, no, it's very big. One screenshot so that you can do it. So import math, same. We are creating imaginary root exception with the help of class error. It is a base class for all the exceptions, ABC values, trying it. Finally, you're calculating. If any errors, you'll display. Okay, let me run this code. Now, it is asking enter value of A. I give 4. Enter value of 5. B, 5. Value of C, 3. Imaginary roots. It is displaying the imaginary root. So, B square, 25, into 4 into 4, 16, 16 into 3, it's bigger. So, 16 twos are 32, that itself it is more. 16 threes are, okay, 51, it's more than. So, more than whatever you are getting. So, it's imaginary root. Now, I run it once again. And I make A as 0, B as 5, C as 1. invalid operation, floating division by 0, because this arithmetic expression, it will come into play. So any number you divided by 0 is not accepted. Now, I run it again, once again, another time. A value I give it as 2, B value 5, C value 1. Yes, the solutions are minus 2.28 to 0.219. So these are the two solutions roots. Like this, you can calculate. Okay, this is a code. This is a code, and runtime exception and doc test are very closely related. That's why I have taken that simultaneously. And that's all for today's class. Next class, we'll discuss about module 3. That's the end of module 2. Um, please type in your uh, USN in the attendance box. Chandrasekhar, the CR, please note down. Thank you. Be safe. Have a wonderful day. All class recordings, notes, everything is available in this particular website.